All right, so day 2 of limit review. Again, we'll just be doing some brief notes here at the top, and then we'll work some problems together and hope that you remember what's going on. So, evaluating limits algebraically. There's some techniques we need to know. Again, write small and it'll all fit up there. So, techniques for evaluating limits algebraically. Our favorite technique by far, does anybody know what it's called? What we do first with limits? It doesn't always work, but this is what we try first. It's been a long time since you were in any math class. Your first go is substitution. So always try it first, because if it works, and works is kind of tricky, but you'll know if it doesn't work. You get a weird answer that doesn't make sense, then you got to do something else. But if you plug it in, you get something that looks normal, then you roll with that. And because it's so easy, most of them are not substitution problems. On the other hand, this is one place where people will miss the easy ones because they jump past what should be their first try into the harder things, because most of them are the harder things. So people end up missing the easy ones because they're trying to do the harder things on an easy problem. So I'll try to remember to always start with substitution, even though after the first 3, I think, we won't use substitution because it's just too easy. So substitution is first. I guess let's do examples as we go. That's normally how we do notes. So let's look at example 1. So we'll kind of tie these, or example 1, I mean like problem 1. So we'll take notes and do an example and take more notes and kind of hop back and forth like that. So substitution means substitute the number in. So on number 1, limit as x approaches -4 of this thing. So let's just plug in -4 and see what happens. So -4 goes in for x. (16 minus 4 is 12). -4 minus -4 is -8. And, oh yeah, we're in calculus now, so that is a safe stop. We do not have to reduce fractions. In fact, if the problem is calculator ready, you don't have to go any further. So even the step before that is a safe stop. So this is sort of a side note about AP. On a free response question, you could leave it like this, because that's ready to just plug into a calculator and get an answer. Right? We want to test your calculus, not your computation. So if you leave that, you are okay. Now, I usually don't leave it that bad. I usually clean it up a little bit. And I realize, oh, that'll reduce, but I don't want to mess up reducing it, so I'll stop there. So you can do that. That is okay. In fact, it's encouraged, because if you stop there, you get all the points on the problem. If you reduce and make a mistake, then you're going to lose a point. So be careful, and I would stop short when possible. The warning to that is, or the caveat to that is, on multiple choice tests, they don't leave it as safe stop answers. They take it all the way. So it's not like you can say, oh, I never have to reduce a fraction again. No, if it's a multiple choice test, they're going to go ahead and reduce that all the way down. So all of those answers are the same, so they're all acceptable. If you have a choice, you should stop here. If it's multiple choice, they're not going to leave it like that. They're going to make sure that you can get all the way there. Okay, that was sort of a side note there. Big picture, substitution. We plugged in -4. We got some kind of normal answer, so we're good with that. That's our answer. That limit is -3/2. Pretty simple. Why don't you try, because this will be a good review, you try 2 and 3. Those are substitution problems. And you might have to reflect or remember the unit circle stuff, absolute value stuff. So try 2 and 3, and then we'll go over those in just a second. Okay, let's work backwards. Number 3 should be easy. 5 plus 2 is 7. 5 minus 3 is 2. And actually, this would be a safe stop. But multiple choice would take it all the way to 7/2. So that's an easy one. You get a nice answer, you're good. The limit's 7/2. Let's back up and talk about unit circle. As a review, I'll show you how I do it. Some of you didn't have me for pre-cal last year, so you might have slightly different takes on the unit circle. I draw the angle, so 5/3. I know that that's steep angle, fourth quadrant. So I draw my steep angle in the fourth quadrant, and then I can just tell by looking what side is x and what side is y. Tangent, I remember, is y over x. So y over x. Cosine is just the x. And even though that looks terrible, that would be a safe stop. I mean, it looks awful, but it's a safe stop. If I wanted to clean that up, for the tangent, so the tangent first, I would keep it, change it, flip it, oops, and get negative square root of 3. So negative root 3 over 1/2. And then I would keep, change, flip that, and get negative 2 root 3. So either of those are acceptable answers. Again, the difference being safe stop. If it's a free response question, leave it like that. If it's multiple choice, it's going to look like this. I say leave it like that. Some of you might have tangents memorized, and so you would leave it like this, and that would be okay too. Questions on either of those? Like either from the limit perspective or the unit circle thing? So that there really wasn't calculus involved in those problems. It was just substitute it in and get an answer. So always try substitution. If it works, great. The bad news is it's not going to work very often because there's more. There's some tricks we have to know. That's the official math term for the second type of problem here, is these tricks. And there's 3 different types of tricks. I guess the good news is it's usually pretty obvious which trick to use. So one trick is factor and reduce. So you peek ahead on the worksheet at number 4, say. That looks like a factoring and reducing type problem. So let's peek ahead at number 4. We should always try substitution first. And I guess I should do it first because you'll see why it doesn't work. If we plug in 4, 16 minus 16 over 4 minus 4, that's 0 over 0. But that doesn't work. Like, you can't divide by 0. And 0 over 0 is indeterminate. That's a kind of a separate topic, but that's not a good answer. So I got to do something else. But we substitute first to see that that doesn't work. Then we can think about our tricks. And again, if you start looking ahead, just on the side of the worksheet, I feel like there's very different looking problems. There's polynomials that you can factor, and then there's a set of fractions to do something with, and then there's some square roots to do something with. So if it doesn't work, you got to use a trick, but which trick to use is usually not hard to figure out. Okay, back to number 4. Limit as x approaches 4, x plus 4, x minus 4, all over x minus 4. Ah, that's convenient. The x minus 4s will cancel. And that was the problem, right? If we plugged in 4, we were getting 0 over 0. Now maybe we see why we were getting 0 over 0. So those factors will cancel. And then after we factor and reduce, it always comes back to substitution. So after you do the tricks, you're going to still substitute. So you're always substituting. Maybe it works, maybe it doesn't. You do the trick, and then you substitute again. So let's plug in 4. 4 plus 4 is 8. Okay, easy problem. Okay, a little bit of a sidetrack here. Do you remember what in pre-cal was happening if you canceled an x minus 4 top and bottom? That makes a hole. If you canceled top and bottom, that made a hole. Now, I have no idea what this thing looks like, but I know what a hole in general looks like. Something like that. Now think back to what we did yesterday. The function doesn't exist there, right? So if we tried to plug in 4, it didn't work because it wasn't there. It kind of messed things up. But the limit does exist there. And the limit exists there because we were able to sort of remove that hole and fix it. I mean, it's still there in the original, but the limit exists. So that's trying to connect what we did yesterday graphically with a little bit of pre-cal. Factors cancel, it makes a hole. With what we're doing today, evaluating limits. So factor and reduce, what that does every time is remove the hole. Because the reducing cancels out the hole, and now you don't have a hole, and so you can substitute in and get an answer. Now you can kind of peek ahead. 5, 6, 7, 8, 9. They're all kind of the same type of problem. Not kind of, they are the same type of problem. It's just factoring practice. And you know, in any math class, any chance we get to force you into some factoring practice, we'll do it. And so those next 5 problems are factor, 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 and look for things to cancel. All right, that was trick number 1. Trick number 2, the second thing you can try is to clear the fractions. Clear the fractions. And so you look down at the worksheet, and you're like, well, there's some fractions going on in 10, 11, and 12. 10's pretty easy, so we're going to jump ahead and do 11. 12's a little bit harder, but I don't want to do the hardest one. I'm going to leave that for you. So let's do number 11 together. Clear the fractions. Actually, before I clear the fraction, I should substitute. Because it's possible that if we substitute in, we get an answer. It's not going to work because none of these work. But if I write a problem wrong, or if a teacher is trying to be tricky, they could make it where it works the first time and you don't have to go through one of the trick processes. So if we plug in 0, let's see, we get 1 over 1 is 1, minus 1, plug in 0 in the bottom. Yeah, 0 over 0, so that doesn't work. So yes, we got to do one of our tricks with this one. Okay, what I would like to do is clear the denominators. In fact, that might be a better way to say this. Up here I said clear the fractions. What we really mean is clear the denominators. So we want to multiply through by whatever it takes to cancel all the denominators. Well, in that sense, number 11 is easy because there's only one denominator. So let's multiply by x plus 1 to everybody. But I can't just do that in the top. That would change the fraction. So let's also do it in the bottom. So I'm going to multiply x plus 1 to both terms in the top. On that first term, well, I'll show everything to start with here. Write it all out. Many of you are not going to write it all out. You're going to do some canceling and algebra steps in your head, and that's certainly okay. So on that first one, the x plus 1's cancel. So x plus 1 over x plus 1 makes 1. Careful with the minus sign. That's maybe one of the reasons I picked this one, is to make sure that minus sign goes to the x and to the 1. So minus x minus 1. And then the bottom is already factored, so I don't really want to distribute that and make it x squared plus x. Okay, that wouldn't be wrong, but it would not be helpful. So let's leave it as x times x plus 1, because I want something to cancel. If something will cancel, then I might be able to substitute. Let's see, the 1 minus 1 goes away. Negative x over x would reduce to negative 1. So we canceled something. When you cancel something, you remove a hole, or that means there is a hole there. But now let's substitute again. And I guess if I was being formal and I had all the room in the world and all the time in the world, I would write limit as x approaches 0 in front of each of these statements. But we get a little lazy on that because it's just tiresome. 0. Substitute 0. Again, it always comes back to substitution. So negative 1 over 1 is negative 1. And there's our answer. Questions on that? So today's a lot of algebra review. You're doing calculus. The calculus isn't the hard part. The algebra is the hard part. In fact, most of the issues in calculus, I think I can even say that, most of the issues in calculus will be algebra issues. Like you'll understand the calculus, but can you do all the algebra steps to get there? Okay, so back to big picture here. Always try substitution first. If it doesn't work, meaning you get 0 over 0, you have to try one of the tricks. Factor and reduce, clear the denominators, and lastly is with square roots, we'll multiply by the conjugate. Multiply by the conjugate. This is going to be another algebra gymnastics going on here. So you look at 13, 14, 15, there's lots of square roots going on. Let's do number 13. So peek ahead to 13. Oh yeah, got to substitute first, or supposed to substitute first. Let's see, 2 plus 7 is 9, square root of 9 is 3. Substitute 2 in the bottom, 2 minus 2 is 0. So yeah, 0 over 0, we've got to do something. And the something is multiply by the conjugate that involves the square root. So it doesn't really matter if it's in the top or the bottom. All of these are in the top. But multiply by the conjugate that involves the square root. And then algebra. When I say the conjugate, do you remember what that means?
Sign.
Yeah, change the sign. And be careful, don't change the sign under the square root. Just change like the main sign there. So that's what a conjugate is. So the square root of x plus 7 plus 3 over the square root of x plus 7 plus 3. Okay, so I got a major FOIL problem in the top. It looks awful, but as you start to do it, things are not so bad. So the first of FOIL, first times first, square root of x plus 7 times square root of x plus 7.
Plus 7.
X plus 7. So that one's not bad. That's just x plus 7. Okay, the O and the I, the outside and the inside. Well, the outside is plus 3 square root x plus 7, and the inside is minus 3 square root x plus 7. That sounds like a mouthful, but it all equals 0. Because when you multiply, that's why you multiply by conjugates, to make the O and the I cancel out. So I guess it's the first one, I'll show it. But the hope is you recognize and understand that by multiplying by a conjugate, the O and the I cancel. That's why you multiply by a conjugate. And so you don't really have to show that. We just understand that that's going to go away. And then negative 3 times 3 is negative 9. On the bottom, don't distribute, because the point was we want things to cancel. So yes, I could distribute the x and then distribute the 2, and that really would be a mess. But I'm hoping something will cancel. So I'm not going to distribute. I want to leave factors. And then in the top, 7 minus 9 would be minus 2. And then, well, even though these are kind of tricky, they've got these built-in little treats inside them, like, oh, I'm on the right track, because the x minus 2's will cancel. Which, if we were really thinking ahead, 2 is a problem, So that meant x minus 2 should cancel somewhere. So now let's do the limit as x approaches 2. Plug 2 in right here. 1 over square root of 9 plus 3. That is a safe stop. That's kind of a weird safe stop, but you could leave that. 3 plus 3 is 6, so the answer is 1/6. Calculus is easy, algebra is hard. Hopefully not. All right, you can see 14 and 15 would be pretty similar problems. Look at the back of the worksheet. Those questions come from AP Classroom. We'll get signed up for AP Classroom once classes sort of level out and everybody's in the right spot, because if we do it now and you get signed in, then we have to change it. It's kind of a hassle. But anyway, have y'all had an AP class before where you had My AP? Okay, so some of you are familiar with it. Has anybody not used AP Classroom before? Okay, so you'll sign up, and we'll do this together once it's time, but AP Classroom has a ton of resources, and we'll do some of them online. Other times we just pull them off of there and put them on our worksheets. But if it says AP Classroom, that's a big hint that, hey, this is AP stuff that could be on an AP test. So this is all the same kind of stuff we were just doing. It's just multiple choice and maybe arranged a little differently. Okay, so your assignment is the rest of worksheet 2. I do need to peek ahead. I don't know that I said this yet. Forgive me if I start taking things for granted, since I had half of you last year. I'll usually take up homework once a week-ish, but there's no point in taking up homework tomorrow when we've only done 2 things. Plus, I usually like to give you 2 nights to work on something rather than just one. That way, if you've got practice or you're overloaded and you got to study or whatever. So I would very rarely take up something the next day, because I want to give you 2 nights to work on it, think about it, process it, or whatever. All that to say is, come next Wednesday, we'll turn in basically all the homework. Worksheet 1 through 5. How I will grade it is mostly completion, but a little bit of accuracy. So what I'm going to try to do is grade like 2 problems from each worksheet for accuracy and just straight up right or wrong. So if you miss those 2, but you do everything right on the worksheet, or you complete the worksheet, you'd make an 8 out of 10. So the absolute worst you should do is an 80 on the daily grades. And that would be if you missed 2 on every single worksheet, which would be kind of a dumb thing to do because the answers are posted. So, you should make hundreds on your daily work. Now, not everybody goes to the answers, not everybody does everything, so I will continue to grade it and look at it to basically benefit those that do what they're supposed to do, and those that are not, then that'll be reflected in their daily grade as well. That's not most of you. Most of you are going to do what you need to do and have all hundreds all year for your daily work, which is what you ought to have. On the other hand, if you go the other way and all you do is copy my answers, then you'll make 100 on the daily, but you'll make a 52 on the test because you didn't do anything. So that's up to you, right? Not really preferred, but hey, can't control. So I think it's a good balance of trying to hold you a little bit accountable, but also putting it in your court. You need to do what you need to do to be successful in here. Questions on anything?